I've been struggling a bit with fire all weapons. I was trying to figure out what went wrong, and then it hit me. I'd heard this term for years, but I never really understood it until I started learning about software architecture. And I started to realise why I was having so much difficulty. I used to think the most important thing in coding was how well your code runs, but that's not the most important thing, that's secondary. I'm reminded of the words of a famous nerd.
What's the most important aspect about any game? Well, being able to play it.
And similarly, the most important aspect of making a game is being able to make it. Every step you take to build the game needs to be in service of the next step in building a game. But what so often happens is you end up focusing on what makes the game run, and you lose sight of the fact that what you just did made the code harder to read and build on. So it just keeps getting more and more difficult to add more features until everything seizes up and the project grinds to a halt. And this is exactly what happened to firewall weapons. The code is a sticky mess. So I'm gonna pull it apart and put it back together. This is gonna get ugly. So what exactly is wrong with it? Well, probably a lot, but the worst of it was twofold. I was violating the single responsibility principle, and I wasn't making sure that the classes had high cohesion and low coupling. What the hell does that mean? Basically, every class should do one thing, and everything in that class should be working together in a cohesive way. Classes shouldn't be communicating with each other any more than necessary. I had classes that were doing several jobs, and the classes were all getting into each other's business too much. This is where the spaghetti comes in. All those strands of connection meant that changing anything sent waves of unintended effects through the code, which I then had to go and fix, causing yet more waves. Here's an example, the cards themselves. There's really two sides to these cards. Well, not literally, I didn't draw a card back, but what I mean is there's the logic of how the card affects gameplay, how they move from the deck to the hand, get played, go to the discard pile and so on, and then there's the visual and interaction element of the cards. I'd shove the card logic and the visual aspect of the cards together in a single object, and this created a problem. I was working on a feature where some cards would get removed from your deck when they're played, specifically the Fire Missile card. When you play it, it fires a missile, and then you don't have the missile anymore, so the card gets removed from the discard pile so it doesn't come back around to your deck. But the missile itself still exists in space on the way towards the enemy ship. Problem is that the card has all these references to the missile object and logic about what to do when it hits and stuff. So when the card gets removed, everything breaks because the missile still expects to have the card around. I tried in vain to figure out a way to deal with this. Maybe I could keep the card around in limbo for a while and check every turn to see if the missile has been destroyed. But that's clunky and not good, and I also wanted to have the possibility of persistent effects created by cards that are getting removed from your deck, like spawning a drone or something. The point is, I don't want all these cards full of UI elements hanging around when there's no reason for it. It's messy, and it's just going to keep creating problems. This is just one example of the problems I was having, and there are surely more issues waiting to be discovered if I don't tidy this up before continuing. So let's fix this. There are two sets of classes that form this knot of code, the cards and the card containers. The card container class is the abstract parent class for things like the deck, hand and discard pile. This class has a bunch of functions that move the cards between these containers. The card container itself is just sticking to that one job, but it's the subclasses where things get messy. For example, the hand class introduces functions that handle user interaction and controls the position of the cards. The card holder is a container for the card that you've selected and are dragging around the screen and deals with user interaction for that. Card queue handles the logic for carrying out the actions of the cards, like firing a missile, and also creates a visual queue of cards when they're played in quick succession. This is way too many things. Too many being more than one. In order to make the card containers stick to their one job, the card class needs to change too. Right now, cards are composite game objects containing components that deal with interaction and visuals of the card. None of that is necessary for the task of simply keeping track of what the deck, hand, discard pile and so on are doing. So I'm going to separate this into two layers. The bottom layer will contain all the game logic associated with the cards, and the upper layer will deal with all the visuals and user interaction. The visuals and interaction layer will need to know about the game logic layer, but not vice versa. Ideally, it should be possible to build an entirely new UI without altering anything in the lower layer. Building a system like this makes it possible to alter the UI without affecting the game logic. Altering the game logic layer may require making changes to the visuals UI layer, but because of this one-directional dependency, it won't cause the kind of cascades of problems that we had before. I decided to use composition rather than inheritance for the card containers this time. This allows for greater flexibility, but can be a little more difficult to conceptualize. Instead of the deck being a type of a container, the deck object has two components. The pile, which has functions that are common to every type of container, and a deck component for the specific tasks that are associated with the container being a deck. Creating these classes wasn't too tricky. I just copied all the relevant parts out of the equivalent classes and left out all the UI stuff, therefore creating a parallel system of abstract cards that could move around between the piles without any visual aspect. I left the old classes in place and renamed them hand old, deck old, etc. Then I just tried removing these classes at this point with the intention of rebuilding the card UI. But because of all the spaghetti tendrils that connected it to other parts of the code, it was like tearing out a vital organ, and all the veins and connective tissue and stringy bits all just ripped apart, and the code died choking on its own compiler errors. So I realised I was going to have to do some very careful surgery, slowly detaching each of the connections to other parts of the code. This is why you don't let these kind of tangled messes happen in the first place. It's like when you go into that drawer full of cables and you can't get just one out, you have to remove a solid cube of cable matter and hope that you get the wire you want without ripping everything apart. So began the long process of renaming and refactoring all these classes and finding new ways to connect things together that didn't create a new mess. This took ages. The details of this are long and confusing, so I won't get into the nitty-gritty of the changes I made, but it was messy. Part of the problem was how I was getting references to everything. I had this big singleton called scene references. It's just a long list of every object you might want to reference to, with the values set in the inspector. I was using this technique all over the place, and it's part of why untangling everything was so difficult. There is another way to get references though, several in fact, like the find object of type method. I originally didn't think this was a good idea though, because it's a lot more expensive to use in terms of processing power. But computers are fast. If you're not doing this sort of thing too often, the performance cost is not noticeable and absolutely worth it to make the code easier to work with. Removing the scene references class and replacing all of the references it used also took a lot of doing. In order to do that, I had to come up with a new system to get a lot of these references. When there's only one instance of a class, you can just use the find object of type method and there you have your reference. The part where it gets tricky is when you have objects that are generated at runtime, like the enemy ships for example. They don't exist until after the code has started running. So I created an interface called IOwnable, which is implemented by anything that can be owned by a player or the enemy, like a ship, and an ownable finder class that gets a list of all IOwnables and searches through them for the type requested and the type of owner. This is pretty flexible and it can be used for anything that can be owned by a player or an enemy, like a missile. I'm not sure yet if this method will be too processor intensive to use everywhere that it's useful, but I still think it's a useful tool going forward, and in most cases it's going to be worth the trade-off to make the code more readable and usable. In the end, we have two well-separated layers. The UI layer looks to the game logic layer to determine when to show the cards in the hand and the queue and such. To achieve this, the classes in the UI layer subscribe to events in the game logic layer, such as on-card play and on-card discard. This allows the UI elements to be controlled by the layer below without the layer below knowing anything about the layer above. And now the missile problem is no longer a problem. Keeping the abstract card object around is not really an issue because it's just a simple object with a script running on it. It also means that the visual and UI elements of the card only need to exist for the cards you can see. No more stacks of unnecessary UI cards sitting around in the deck and discard pile and so on. Going forward, I'm considering adding another layer for the combat itself. Things to do with the ships and the weapons and the way they interact with each other. The combat layer won't need to know anything about the card layer, but the card layer will need to know about the combat layer, so it's another one-directional relationship. Separating the combat into a separate layer should make it easier to manipulate that layer without getting involved in the cards and the actions. It is possible to add too much abstraction though. It will never be perfect, and at some point there's going to be diminishing returns. Finding that balance is tricky. This is one of the things I've been learning about software development. The art of it is in figuring out a way to build these systems on a large scale. There's no one right way to do it, and the details of what constitutes good or clean code is still an ongoing argument. There are some fundamentals I wish I'd picked up earlier though. That's the danger of being mostly self-taught. When you learn everything from online tutorials, it does give you a great way to build all the different pieces of a game, but being able to put those together in a coherent way where everything works well, there's no one simple tutorial for that. If you have any thoughts about what I've said here, I'd love to hear them, especially if you have any advice about software architecture. And now that I've got the mess tidied up, I should be able to make some real progress on this game. Thanks for watching. And stick around for the end of the video because there's a fun little surprise coming right about now.